This is Chapter 7, Part 2. We left off last time talking about the use of multiple indicators as a more sophisticated way to measure your concept. Here we have on this slide a list of reasons why it's a good idea to use more than one indicator. Now just remember this term here. Indicator is like a single question, a single item. And now that's another word that they'll use for this is item. Or indicator, that means a single question if you're using a questionnaire to measure things. And so we might want to use multiple questions. Single indicators may incorrectly classify many individuals. So again, it's crude if you use a single indicator. And so if you just, here's an example. If instead instead of asking people how many times they've been violent in the past 12 months, if you just said something like, "Are you violent? Yes or no?" Yes or no, that might misclassify a lot of people. It's one question and it's crudely kind of conceptualized here, where you might get people who actually really are kind of violent saying no, and people who aren't violent being kind of hard on themselves and saying yes, that they're kind of violent. So you can get misclassifications if you're using a single question, and especially if it's crudely put together. Single indicators may capture only a portion of the underlying concept, or they might be too general. So that one, "Are you violent? Yes or no?" is kind of too general. And we already talked about how a single indicator may only pick up one dimension. Say, for example, if you ask, "Have you ever pulled a weapon on somebody?" Well, that's might be a good question, but it doesn't capture less violent actions, and probably few people on a sample, on a survey, are going to have pulled, say, a knife on somebody. Not too many of them, but a lot more people might have gotten into a fight at school, attacked somebody physically, and that's still violence, and we want to study that too. So a single question may not get at everything you want to get at. Multiple indicators can make finer distinctions between individuals. So you end up getting, think of it like a scale, like a ruler, that if you ask more questions, then you can measure more accurately than, say, just round it off to the nearest inch. If you have a lot of questions, you think of it like that ruler, where you can get it down to the closest 1/16 of an inch. Really small little differences. Or like, think of a stopwatch, where you don't have to round off to the second, that do a foot race or something like that, and just round it up to the closest seconds. Instead, it could maybe, with these some of these are very precise, where it'll tell you to the 100th, 2 decimal places, how fast you ran the race or something. See, so that's what we mean by refinement. If you ask more questions, then you can distinguish people who are close together and similar in their violence, but one is just slightly more violent than the other one. You have to have a fine type of measurement to be able to detect that. Multiple indicators can capture different dimensions of a concept. So we've already talked about that one. Concepts, sometimes there's lots of different aspects of what you're studying, and you want to try to measure all of that. Okay, now we've already talked about reliability in a previous chapter, and these authors have a tendency to sort of hit a lot of themes again and again throughout the textbook, which sometimes it irritates me. But sometimes there are additional topics that we want to pick up, and so let me spend a minute on this. With quantitative stuff, as we talked about before, we are very concerned with reliability, meaning consistency, that when you step on those scales multiple times, it's going to give you that same, 175 pounds or whatever that weight is. It's going to give you a number close, if not exactly 175 every time you step on the scales. It's going to be close to that. Well, stability is a related term, a related idea. Is the measure stable over time? And so if it's a good measure and we're measuring something that kind of stays the same from one moment to the next, then you should get the same number over time. So let's say once you're fully grown, your height shouldn't change. It should be stable. If you're 5'8", you should be 5'8" a month from now, 6 months, a year from now. And so for your measure to be a good one, it needs to give you 5'8" every time you get measured. It should give you 5'8" or something really close to it. If it doesn't, if it tells you one time you're 5'7", another time 5'9", another time 5'5", another time 6 foot, I mean, you're all over the place. It's not a stable measure. So stability gets at the over time issue. Does it stay the same over the time? And the example they put here is test-retest method. So that just means, test you the first time on whatever it is, measure the first time. Then they wait a certain period of time, measure again, and you get the same measurement. And if something like high E better, and so realize that test, we have a certain, as students and teachers, we have a certain understanding what that means. That you take a test, right, with a bunch of questions. But a test could actually be just any kind of measurement. We're trying to measure you on something, and so that sometimes we'll call that a test and retesting it. But it really could apply to just about any time you're measuring something. Okay, this internal reliability are the indicators consistent? And one technique they'll use to try to find out if the indicators are good and consistent, your measurements are good and consistent, is use this split half method, where we'll have say one half, maybe you're going to give a test to students to try to measure their knowledge on the latest few chapters from the book. So you give them a test. And one technique they'll use to see if the questions are good on the test, if they're clear, and if you get the answer to the question correct this time, would you get the same correct answer to that question next time if you took it again in a month or something? Or is the question really poorly written, where it's vague and confusing, and so you're lucky and you get it right this time, but you take the test again in a month and you get it wrong next time? Oh, that's a sign that your questions are kind of not very good questions if people can't consistently, get them right if they know the information, right? So this split half technique, what you could do is you could take and give a test to your whole class, split the class in half, and see if people, if one half of the class was just as good at the other class on the questions. So if you saw that the students were consistently got the right answers in one half of the class, and the other half of the class, and consistently got the wrong answers in one half of the class, and also missed the same questions consistently on the other half of the class, then that's showing you that, okay, it doesn't really matter which group is taking the test. It doesn't matter the group of people. It's testing like it's supposed to. The people are reliably answering it correct if they know the material, and reliably getting it wrong if they don't know the material, because both halves of the class are doing the same performance. So it's not about the students. It's the test seems to be doing a good job. So that's just one technique that they'll use to see if the questions are good questions, if they're doing what they're supposed to do, testing your knowledge in a reliable, consistent way. And finally, this inter-observer consistency, what they mean by that is the measure consistent between observers? So, for example, you'll see studies, just a random example of where they look at people's physical attractiveness. And you want to measure their attractiveness. Beauty is a little bit in the eye of the beholder, but maybe if we have 5 or 6 judges and they all agree, so you show pictures of individuals and you say, okay, rate this person's physical attractiveness on a scale of 1 to 10. And if all of the people on this panel, all of the judges give people really close to the same scores, everybody gives this person an 8. Everybody gives this person a 5 or a 6. They're all close together. That's what they mean by inter-observer consistency. Is the method that you're using, does it result in different people giving the same judgments, giving the same ratings? If everybody's on the same page, then that means that your method of how you're measuring things is probably a pretty reliable, consistent method. If everybody's given answers all over the map, you show everybody this photograph of a person, and one person says 9, another person says 2, Another person says 4. They're all over the map. Well, it's like that's not a method of measurement that's going to work very well because people are not on the same page. They're not giving the same answers. So you're lacking inter-observer consistency. That's what I mean by that. So you've got if you're going to use judges, more than one judge, they all need to be on the same page. For it to be reliable. Okay, now what does validity mean? Now there's a little bit of getting into the weeds here, but reliability and validity are really important, especially for quantitative research. So let's take a moment on these. You do want to understand through your own studies and also listening closely to me now, you want to understand these different types of validity because they're certainly likely to show up on a quiz. Face validity is common sense. Remember, validity is are we hitting the bullseye? Are we measuring what we think we're measuring? Let me give you a personal example of where there's a face validity problem to help you understand better what it is. Back when I was in graduate school, you have to do a big research project, basically like the length of a book, a dissertation, to be able to earn your PhD. And so I decided I wanted to compare countries all around the world to see if there was a connection between how common it was for citizens to own guns, and was there a connection between that and the homicide rate in a country? Did countries that have more gun ownership, did they have more homicides or did they have fewer homicides? Or was there no connection? That's what I wanted to look at. Well, the problem was, at the time I did the study, there wasn't a large sample of countries that had good data on guns. And so I looked at the research, I did my literature review to see what's already out there, and I saw that everybody used a weird measure of gun availability, how many guns are out there. They used a measure that was the percent of all suicides that happened in the country that were committed using a gun. So in the United States, an average year, you probably got about 65% of Americans, if they take their own lives, they use a gun to do it. And whereas in a place like Japan, where nobody has guns over there, and if someone takes their own life, commits suicide, they're very likely to use some other sort of means to take their life, and the percent of suicides where people use guns over there is very low because they don't have many guns. So that was used as what you call a proxy or a substitute measure of gun availability, of gun ownership, because we didn't have anything better. So I did the paper based on that, and then I sent my paper to a journal to get it published in a peer review journal, with experts kind of signing off on my paper, and they didn't sign off on it. They said, one of the reviewers said, you know what, this percent gun suicide thing, I just don't think that that's a good measure. It lacks face validity. It just doesn't make sense to me. I mean, you're looking at people committing suicides, and that's just a small little part of the population. That's a rare kind of event. Most people don't do that. I just don't think it measures guns very well, so I'm going to reject your paper. So they didn't publish it. I got to publish someplace else, but these guys didn't want to publish it because it didn't make sense to them on the surface. Just looking at it, that's called face validity, common sense kind of, does it seem like a good measurement or not? They didn't buy it. Okay. Now, concurrent validity, you need to understand that one is best to compare it with this next one, which is predictive validity. Concurrent validity refers to, does the measure predict something that's going on today that it should predict, that you would expect it to predict. So, for example, if I was to give a quiz to you folks, and the truth is that you're an A student, that you're an excellent student, you're always the top of your class. And so, we just happen to know that that's the truth. Let's just imagine we know that. And I give you a test and you do really poorly on it, but you did everything right and you always get A's and everything, then that's evidence that this quiz is probably missing the target a little bit. It's not particularly valid because it's not predicting what it should. We know, let's say we just happen to know based on other things, that you're always getting A's and you didn't on this test, and there was nothing you did any differently, and you can, it could be just bad luck. It just could be an accident. But it could also be, well, maybe the test wasn't designed to really measure very validly the knowledge that you were supposed to have gained and prepared and got yourself ready for, right? By learning that knowledge. So concurrent means that we're measuring how well does the test measure what it's supposed to, of where you're at right now. Concurrent means at the same time. So if your skill is an A student right now, then that test, to be a good, valid test, it ought to predict, it ought to say that you should end up doing well on it. You should get an A on that test, or it's not matching up with how you really are. Okay, that's concurrent. Now, predictive validity is the same sort of thing, except it's talking about the future. So a real good life example of predictive validity is, right now there's some controversy about the test that you take to college, this sort of college entrance exams, whether it's the ACT or the SAT, or if you're going to graduate school, a lot of times you have to take the GRE exam. These are all standardized exams which are supposed to predict how well prepared you are, what your abilities, your skills are, and it's supposed to be able to predict how well you're going to do in college. And so if you take that test and you get a really high score, and then you end up doing really well in college, then that's evidence that that test is predictive. It's predicting what it's supposed to, how well you're going to do in college. If it doesn't predict well, if you get a really lousy score on SAT or ACT, but then you end up really nailing it and you do a fantastic job while you're in college, and you're just very successful and you get great grades and, I don't know, graduate with honors, well, then that's evidence that the test doesn't have very good predictive validity, because it's predicting that you're probably not going to do very well in college, so you got a low test score. And yet you did do really well in college, and so that's evidence of low predictive validity. And so that's right now is a controversy around the country. Like a lot of, ISU is sort of dropping the requirement that you take this GRE test to go to graduate school, to get into graduate school, because people have sort of lost their belief that the tests are predictive, that they do a good job of predicting, and that they're helpful in deciding who to admit into programs and who not to admit into programs. So that's sort of what the controversy is going on right now. We don't need to get into, which side is more right about that. But anyway, that's an example of predictive validity. Does it predict accurately something that's supposed to happen in the future that it's supposed to be able to predict? Does it or does it not? So again, the difference between concurrent and predictive is concurrent is predicting something now, and predictive is predicting something in the future. Okay. Construct validity, we kind of touched on this one before, so I don't want to spend a lot of time on it, but it's just basically, have you put together your measurements in a way, have you come up with a list of questions? Like when we were talking about different types of violence, weapon violence, no weapon violence, threats of violence. Did you come up with a list of questions that's covering everything in your concept of violence, so that everything is represented and you're capturing all the dimensions of it? So it's basically the design of how you go about measuring this, and are you really covering everything fully, and does it end up giving you good results, that kind of thing. So just think construction, putting it together and doing it in a way that's thorough, and I think that's the best way to think of it, as thorough coverage of everything that needs to be covered. Now, convergent validity, this one is important. Is that they've got here supported by results from other methods. So here's a term for you that you should know that goes along with convergent validity. It's called triangulation. Triangulation. Now, what does this mean? If in criminology, we'll study crime by using different sorts of research methods and different sorts of data. For example, we'll use, an obvious place to go is to use police data. For example, what are the reports of crimes to the police? How many burglaries have we had in town, or how many robberies or assaults? Well, let's see how many have been called in and recorded by the police, right? So police data is one source. One kind of data method, the research method you can use is use police data. But you can also ask victims and say, hey, in the past 6 months, have you been attacked by anybody? You've been your home been burglarized, you've been robbed down the street, attacked in different ways, and we can measure crime by what the victims have to say. That's a different kind of data, a different sort of method. But we can also do what's called self-report data, where we can ask people to confidentially admit to us if they've committed any crimes over whatever, over say the past 6 months or a year or something. Here's a list of crimes. Have you done any of these over the past period, whatever period of time we set? And then rely on people giving us accurate, honest answers. So you have good convergent validity if each one of these methods points to the same research results, points to the same findings. Let me give you a concrete example. All three of these forms of data, police data, victims, and self-report, all of those different approaches find that men tend to be significantly more violent than women. Not everybody, but that's a statistical tendency. So if you have three different kinds of data, all telling the same story, men are the ones who tend to be the most violent, then that really gives you a high level of confidence that it's true, indeed true, that men tend to be a lot more violent than women, because you're using three different, completely different methods. You're relying on three different types of people, and they're all telling the same story, that men tend to be the most violent. So that is converging. Different types of methods are converging on the same results, the same findings. And another term for that is triangulation. Triangulation, for some reason that term always makes me think of like the Kennedy assassination, for that there's conspiracy theories that you actually had more than one shooter, and that if you want to assassinate somebody, a smart technique is to not use one shooter, to use two or three shooters that are all at different positions, because everybody has their own angle. And if my shot is blocked by somebody or some object, a vehicle gets in my way, well, maybe you'll have an open shot, you're in a different position. Or maybe the other guy will have an open shot in a different position. So if you triangulate, you can hit your target one way or the other. So, it's kind of, I think of it in those terms. I guess I'm using these violent examples all the time, but hey, maybe that's just the way I think, being the criminologist for so long. Anyway, so triangulation, convergent validity, if different methods, if they give you the same results, then that really makes you more confident. Okay, we've got the truth here. We're hitting on something. We're hitting the bullseye. Let's stop right there.